Alright, hello everyone, it's March 25th. Just finished watching Primogens react to some dude submitting 600 applications to get a job. Man, I was reflecting on my job application experience last year. A couple months, 200. 200. I submitted 200 and I got one. Just only one. So I thought it was 200 is a lot, right? Wow, this dude, 600. 600. Man, we all know it's a numbers game. Application, it's always a numbers game. Yeah, but at a certain point, you start questioning yourself. It's every time you got rejected, and you start questioning yourself. Well, really? Am I really that bad? Things like that. The job market for software for tech is definitely not in a good shape. So yeah, if you have a job right now, just keep it, right? Just keep it. I feel lucky, blessed, extremely lucky, extremely blessed. Well, I mean, you can say that's just opportunity, and then I grab it, but still, it's luck. It's a lot of luck, including the interview questions. Yeah, thinking back, I just did LeetCode Premium for a month because I have a lot of points. So I use my points to get a month, and I know the job interview was about JavaScript, and I can write JavaScript, but definitely don't know much about the inner workings of JavaScript. So I used the premium to go through the 30 days of JavaScript. I went through this, really try to study this, and long and behold, one of the questions is almost the same as something there. I still remember. It's a debouncing. Do I still remember how it's done? How debounce is coded in JavaScript? No, I don't. But because I went through these problems, and one of them was to write debounce from scratch, and I have to learn what the hell does debounce do in reality. And because of that piece of information, it helped me in the interview. It's just right there, Yeah, just all these type of luck, right? It accumulates. All right, so we're gonna do this today, and I need to report that I tried to think about this yesterday, and I got nothing. Okay, nothing. I have no clue, no idea how it works. Absolutely zero. I was thinking about if k equal to 1, okay, I think I can do it. There's some combination I can do, and then yeah, there's some ways I can do if k is equal to 1. Okay, that's okay. But how do I extrapolate to k equal to 2, 3, all the way to 20? I have no idea whatsoever. Lord, it's a tough one. It's a very tough one. So I guess I have to check the hints, check Reddit topics. All right, it's a good question. I think it's interesting, but I just don't know how and where I can get my hands on it. No idea. All right, let's do this. Oh, it was a extended version of yesterday's problem. Find all duplicates. Okay. Integer array of length n where all the integers of nums are in the range 1 through n. Each integer appears once or twice. Return an array of all the integers that appears twice. Must write an algorithm that runs at O(n) time and use only constant extra space. I will not. Okay, I will not. I will write the algorithm in O(n) space. I will solve this problem first, and then we'll deal with the other. Is this still hare and tortoise? Yesterday, it turned out it's a hare and tortoise. hare and tortoise, so maybe today is the same. But oh my goodness, but I'm not gonna do that. I am going to not do that. 442. All right, this is on time and on extra space. It is not following the requirement of the question, of the problem, but to hell with it. All right, so n is length, right? So in Boolean, scene nums length, right? Is 1 to n nums length shouldn't be +1. Yeah, I think it should be +1. Oh, we also need a result. List. Perfect. List integer. Okay, if scene n and rest dot add n. Ooh. Oh, either once or twice. Either once or twice. So yeah, this definitely works. Otherwise, scene and equal to true. Right, and at the end we'll return res. Yeah, so you're asking, have you seen it? If you have not seen it before, first time you've seen it, you set it to true. This one shall work. Yeah. Okay, now we need to worry about how to do this in O1 space. No, O1 space, yeah. Oh, here it was. Okay, so we have 4, 3, 2, 7, 8, 2, 3, 1. Okay. So 0, 1, 2, 3, 4, 5, 6, 7. Lordy. So 8 has to go to 0. Damn. Alright, I think it's easier. I just change this. Change the indices. That's okay. So we start from position 1. Right, we'll go to position 4. 7, 3, 2, 3, 2, 3, 2, 3, 2, 3. That's 1, right? And then you need to go to find hold on. So 1, right, go to 4, go to 7, go to this 3, go to this 3. Right, now go to 2. Then go to this 3. So in this case, 3 go to 2, 2 to 3. This is for 3, right? So if we go 1, 2, 1, 2, 1, 2, 1, 2. So yeah, we end up at 2. So we start from here. 1, 2, 1, 2, 3, 3. Yeah. So this one will give us 3. How do we get a 2? So one cycle will give you 1, right? Then you just do I keep going? Or every time you go, you just remove this. You remove this. Remove this. Remove this. Remove this. I'll go to 7, so we remove this. Okay. And then okay, going. Oh. Or you start again. So you got 5. Or 8. And you go to 1. Or go to 4. 4 go to 7. Yes, that's not working. There should be 6 go to 2. And 2 go to 3. And 3 go to 2. Yeah, because you go 6 to 2, 6 to 2, and 2 to 3, and 3 to 2. I think this one will give you 2. 1, 2, 1, 1, 2, 1. So we add a 3. Right, then we start from here, 1, and 1. Yeah, this one will give you 2. So basically you'll find the different types of cycles. The question is how. Do we just keep going? I mean, we can keep track of the largest. Now we start from 1, okay, and then we go through this thing, and then we start from 2, and see it's already done. So we don't go 3, 4, and we start from 5, okay, and 5 we go to 8, 8 go to 1, and 1, you see that one already done, so which means it's already done, so you don't consider. Then you go to 6. that might be the case. That might be the case. So you go from, yeah, you just go through every single one, and you start from 1, and then you do your thing. And once you do your thing, you'll set this all to 0. Yeah, set it all to 0, and then you just keep moving forward. If it's 0, means you handled it before. Otherwise, you keep going. Okay, that actually might work. That actually might work. Oh. Okay, this is extended hair and tortoise method, which will run in on time and on space. Because every number is only hit at most twice. Okay, so we need to private int find duplicate, find dupe. So we need to pass nums for sure, and index. Okay. So when the index comes in, and the index is 1 based, okay? Index is 1 based. Okay. So when we get the index, actually we can do 0 based index. That's totally fine. We just -1 every time when we do this. No, I like index to be this. Yeah, it's more fun. Okay, so index, which means this one has not been visited before. So now we're gonna do is just go from slow, where slow is index, fast is index, right? I say while slow is not equal to index, slow is equal to index, or slow is not equal to fast. Right? And then actually it's one more thing. If slow is not equal to index, or, and then we should and nums slow is not equal to 0. That's our signal of something has already been seen. Yeah, really heck cannot be this. Alright, then we say fast equal to nums fast -1. Right, because indices, so fast -1 is index and I have to index, and slow equal to nums slow -1. Okay. So eventually we'll get out, and then if slow is not equal to fast, that means we just, yeah, it failed. If it failed, then we should just return 0, right? If it's failed, right? If it fails, then we just return 0. And here, every time we visit, we should actually update. Right? We should update. Fast move forward. Well, actually, num slow is not equal to 0, and fast is also should not equal to 0, right? So end. But hold a second, that's actually not true, because once you go here, if you, like I said, I visit these, now you go to 6, right? And 6 go to 2, 2 already visited, so you don't visit it again. That doesn't seem right. That doesn't seem right. You have to visit again, right? You have to visit again, because you want to create a new... The thing is, how do you know that you have... Yeah, I need a way to know, right, when you visit a new node, that it has been considered before, right? So we don't have to consider it again. Well, yeah, that's not right. Right? That doesn't seem right. How do we extend this? So yeah, you start from some stuff and you keep going, and then you do, and then from the second one, you can start again, but it's already been started, so you say, okay, I don't do it anymore. But then how do you... It doesn't work. Doesn't work, man. Doesn't work. Or do you keep track of... But then it has to be O1 in space. There won't be O1 in space. Okay, think again. There's one piece of information you did not use, which is each integer appears once or twice at most. Okay, once or twice at most. So, since they only appear twice, can we maybe consider exclusive OR? Can we? What do you mean by exclusive OR? Like, if we exclusive OR all the values, then the ones that appear twice will be cancelled, right? They will be cancelled. So what we get is all the unique values exclusive OR. Okay, that's fine. We get the unique values exclusive OR. Then what? You have unique values exclusive OR. And can we go one by one these values and try to exclusive OR them? Like, what's gonna happen? Well, what if we do I don't know, a prefix exclusive OR? Okay, a prefix exclusive OR. So you exclusive OR, and when you exclusive OR another value, then do I say... Yeah, no, it doesn't work. It just... that particular value gets cancelled. Right, only that particular value gets cancelled. It doesn't say anything. But definitely we need to use this information, right? This is either once or twice. Very useful. Very, very useful. So if I go through this, okay, everybody's unique, that's fine, and then we find someone that's duplicated. What's gonna happen? what is going to happen is I mean, this one I can modify. Swap? You want to swap? Maybe we can swap this one. Because it didn't say that I need to keep things in check. I can swap. Maybe I can swap. But swap. Then how do we... I mean, swap. Okay, I can swap. Okay, swap. Let's try swap. Maybe swap will work. 4, 3, 2, 7, 8, 2, 3, 4. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So how do we swap? Well, not really swap. That's a 1. Not really swap. This swap idea is actually just the same as the tortoise, but so this is a 1, so 4. So I go to 4. I try to put it in the right position, right? So I put 4 here. Okay, so this is empty. Now 7 is outside. So we go to 7, we put 7 in. Now 3 is a cardinal. 3 comes here. No, 3 comes here. Now 2 is out. Okay, and 2 goes in here. 3 is out. 3 goes in here. Boom. Right? So 3 is the 1. Okay, and then I start with this index. So move on. This is a good. Move on. This is a good. Move on. This is good. Move on. Okay, this is bad. So I will remove this. 8. We go here. Now it's 1. Coming here. But it's a 0. So we end. Right? So now we go 4 is good. This is no good. 5 is no good, but we don't know which one to put in here. That's fine. Now we go to here. All right, 6. So we go to 2. All right, so we take this out, go to 2. It's already there, so 2 is the other one. Right? And then, oh, I think that's the one. Swapping. That's swapping. Yeah, so the key allowance here is they didn't say I cannot modify nums, right? So I was still sticking to yesterday's problem. Yesterday's problem is nums cannot be modified, but here nums can be modified. They never say that I have to keep nums the same, right? I just said only use extra space. So because of that, I am going to just change nums for sure. So this is no, this is not extended version. This is the swap. Okay, the swap method. And we're running on. Okay, yeah. We don't need this. We do need this. And swap. Let's see. So what we need is for int I equals to 0, I smaller than nums dot length I plus plus. Perfect. And then here is the swap. Okay, swap. So int temp, right? Go to 0. Doesn't matter. We get a temp out, and then temp need to hold the current one that gets out, right? Okay, so we say while temp. Actually, let's just do temp is equal to what? Temp should be equal to nums I. Okay, when you say while temp is not equal to 0. Okay, Ooh, I is index. Okay, so there's a something tricky here. So anyway, so temp is not equal to 0. Right, temp is not equal to 0. And this is the one we get out. Then we need to move to that location and then put the value in there, right? And we say if nums temp minus 1 is equal to, okay, temp, right? So these two are the same, then temp is a duplicate. We say res.add temp, okay, and it'll break, right? It'll break. Otherwise, if it's not, then first of all, nums I. Well, I don't think I shall handle it here. We shall say nums temp minus 1, right, shall equal to temp. But whatever is the value that's currently in this need to become the new temp. Oh, Gordy, we need two values, right? We need two values. Current and the next. Okay, don't call it temp. Let's call temp current. Current. All right, and then current minus 1 will equal to current. Before do that, we need a next. All right, let's do only 3 letters. So next shall equal to nums current minus 1, okay, and the current minus equal to the current, and then current will equal to next. Right? We swap out and go back up. While current not equal to 0, then we keep going until at a point where we hit some 0, or we hit, yeah, so when we finish nums, oh, current changes. Damn, that is not good. That's fine. All I need to do is set this to 0, because I start from I, right? I start from I. Okay. So we shall say if I plus 1 is equal to nums I, then we'll continue. So this one we don't hit again, right? And we'll hit the first one where I plus 1 is not equal to this, then we get a current out, we get a next, and then if current is not equal to 0, then we'll do all these things, and once we're done, we'll set nums I equal to 0, because I start from here, right? And I get out and this one is empty, so we set to 0. And eventually we'll hold everything, then we go this. Okay, let's give this a shot. Hopefully this one will work. I'm actually not confident at all in this one. Ooh, that was surprising. This might actually work. Nope. All right, let's see. 2, 1. Do 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 do. Okay, 2 1, right? So we start from the first. I go to 0. So I plus 1 is 1 equal to nums 0? No. So in current is 2. Next is 0. Current not equal to 0. That's correct. If current minus 1 is 1 is equal to current. So current is 2. Right? So and then this current is 1. So they're not equal. So next will equal to current. So next will become 1. So nums current minus 1, because it would become 2. Current equal to net. So current is 1. So come back up. Right? Current is 1. Nums 0 equal to current? No. Then next shall equal 2. Next will equal to 2. Oh, that is actually... So 2, 1, right? So this is 1, 2. So we got 2. So we remove this shall be 0 already. And then we'll do this as 2, and then 1 come out, so 1 put in. I need to set this one earlier. Yeah, I just set this one earlier. Do this, then we do this. So I reset this earlier. There we go. There we go. Nice. Good. Not bad. Okay, let's take a look at whatever I did last time. There's some other way to do this. This is a swap. Yep, this is a swap. This is probably this is a counter method. Okay, this is the good solution from the last time attempt. To mark in nums which position can be correctly fulfilled without actually making the swap. You can set the num value as negative to indicate that there is a correct value for the position. What? I'm having a hiccup. Oh. Oh, negative. So you can move there, right? Because you check that current position as a positive, so you can move there. So you set that value to a negative, and then you keep moving on, and then you try it again. If it's negative, that means it has already been moved. Some value has moved there already. So you do that. Oh wow. Yeah. That's pretty smart. Pretty smart. So basically it's saying I don't actually make any swap. I say go to 4. Can I go to 4? Yes. So I set this to -7. 3. Can I go to 3? Yes. I set it to negative value. Right? I'm going to do this. Can I go to 2? Yes, I can go to 2. Because they're different. Right? Because I have one on 2, but that's good. 4. Can I go to 4? No, could I go to 7? Yes, I can go to 7, so that's good. Okay, can I go to 8? Yes, I can go to 8. Can I go to 2? No, you cannot, because it's already negative. So 2. Can I go to 3? No, you cannot. So 3. Can I go to 1? Yes, you can. Alright. That was pretty smart. Oh my goodness. Oh, Lord. This is from the solution from the previous solution. We're still doing the swapping, but without actually making the swap, where each number that can swap to its correct position, right? We set the value at the correct position to negative. A number cannot swap if its corresponding position already contains a negative value. This means the same number must have been swapped there. 4, which means the current value is a duplicate. Okay, so when I say if, so we need to see, alright, so if nums math dot abs nums I, right? So nums I is the current value, and we'll check the current value. Oh my god, I'll check the current value. We'll see where it's going to be. Is it a good one? So minus 1, like if this is smaller than 0, which means we have handled already. Oh, add which one is nums I, right? Yeah, maybe we should do math.abs nums I, because that's the issue, right? That number cannot be handled again. Else, then we simply say nums math.abs times equal to -1. Something like that. So working? Yeah. It works. Remarkable. Absolutely remarkable. All right, that will be it for this problem. Good problem. I always like this one. All right, so for this, since I have no idea, I'm gonna just take a look at the hints, maybe topics. DP. Damn. How are we gonna do DP on this? All right, let's just look at the hints. This first hint means nothing. We can say, you know, number of digits. Or is the previous, we can say is the previous, or the number of evens so far. Oh. Not really. I mean, we want to build a number, or I want to know how many is good number. All right, how many is good number for a certain number of digits? All right, let's say for 4 digits. How many numbers? Okay, 4 digits. Index. We have for an index. Oh. Let Fn denote number of beautiful integers in a range. Oh, it's this method. Fr minus Fl minus 1. I definitely encountered this one before. Okay, we have this hint. Something to think about. Alright, that'll be it for today. The hiccup really getting to my nerves. I'll see you guys tomorrow. Adios.